Днес, 8 февруари 2015 година, при управлението на второто правителство с министър-председател Бойко Борисов, започваме реалното изграждане на язовир Пловдивци и вграждаме това послание в стената му с надеждата, че след 100 години то ще бъде прочетено. Тогава България ще бъде богата, мирна и просперираща държава. Ние поставяме основите на това и вярвам, че с общите усилия на всички мъдри и родолюбиви хора у нас ще успеем да го постигнем.
The dam Plovdivtsi is located in the southern part of the Rhodope Mountains, Smolen area, near the Greek border. The dam is built in the valley of Iskrets River and is located near the village of Plovdivtsi, 14 kilometers away from the town of Rudozem. The dam is a public state-owned property managed by the Ministry of Regional Development and Public Works. It is part of a joint project between the Ministry and the World Bank, Municipal Infrastructure Development Project, amounting to 170 million leva. The project consists of 3 components, where the third one covers the completion of Plovdivtsi and Ludayana drinking water supply dams, the rehabilitation of the operating dams Studena, as well as the rehabilitation of the drinking water treatment plant Studena Pernik. The investment project of the dam Plovdivtsi is planned by the Ministry of Regional Development and Public Works and aims to improve the quality of the water supply for the population of the towns of Rudozem, Madan, Srednogorci, as well as the other 35 villages in the Smolen area, with about 40,000 inhabitants. The construction of such a treatment plant is particularly important for the improvement of drinking water quality. So far, the settlements in Rudozem municipality, Madan city and Madan municipality were supplied with water from 67 water sources, including surface basins and springs. These springs are characterized by a variable debit. This means that during the summer low water flow, the flow rate abruptly decreases, while in the spring and autumn periods of high water, the flow increases, however, the water quality deteriorates. The initial research and design of the project was carried out from 1980 till 1985 by Vodokanal Engineering. The dam is designed as an annual equalizer for the water supply with a total water volume of 2.45 million cubic meters. The construction began in 2000 and continued in line with technical work projects until it was discontinued in 2001 due to lack of funding. After several years, the work on the project was resumed. The contract for the construction of the dam Plovdivtsi and the drinking water treatment plant was signed in December 2014, and the actual construction started in the beginning of 2015. The implementation of the project was assigned to the consortium Plovdivtsi, with leading partners the Russian company Zarubezhstroy, the Bulgarian GBS Infrastructural Construction, and the Spanish Arima. The operator of the dam is Water Supply and Sewerage Smolen. The value of the contract works is 47.4 million leva. Its real value is estimated at about 36.5 million. According to the normative documents, the lifetime of this facility is 100 years. The volume of the dam is 2.45 million cubic meters. The construction of the hydro scheme includes a dam, a cofferdam incorporated into the dam, water tower with drop inlet spillway and low-level culvert, diversion gallery, potable water treatment plant, service building for the exploration of the dam. The type of the dam is rock-filled with asphalt concrete diaphragm founded on a concrete slab 60 centimeters thick. The diaphragm from both sides is connected to the dam shoulders by filters and transition zones. The upstream slope is protected by stone cladding. The height of the dam is 52 meters 25 centimeters, while the length of the crest is 225 meters. A 6-meter wide, single-lane, 3.5 meters asphalt road is arranged along the dam's crest. The stem of the existing drop inlet spillway is built completely above the terrain and is a tower with the parameters as follows: height 40 meters, round cross-section with clear diameter of the stem 4 meters. The diameter of the decaying funnel is 13 meters and the external diameter of the funnel is 13 meters. The latter is formed as elliptical rotational curve. The intake of the low-level culvert is situated on the foundation of the water tower, ensuring this way a total discharge of the reservoir for 16.9 days. The low-level culvert is built of a spiral welded steel pipes. Together with the 3 water pipes, it is incorporated in a common concrete sheath. The alignment of the culvert is parallel to the diversion gallery. At the end, before their connection to the gate chamber, the pipes split, retaining their parallel position to each other at their insertion to the chamber. For regulation of the water discharge of the dam, in the gate chamber, the low-level culvert is provided by an electrical-driven piston valve. The diversion gallery is 224 meters long, with constant inclination of the bottom of 3.46%, and after the reconstruction of the structure, serves for diversion of the high flood after the low-level culvert. The design water discharge Q 0.01%, 160 cubic meters per second, passes the structure free flow. The gallery ends into a plain rectangular canal, at the end of which is constructed a ski jump device. The length of the canal, together with the ski jump, is 26 meters. At the end of the ski jump, 4 baffle piers are designed for reduction of the impact of the falling water on the terrain. The trench spillway is one-sided, with a length of the overflow crest 17 meters and width of the trench 3 meters in the beginning and 4 meters at the end of the structure. The chute is open trapezoid canal with a length of 139 meters and 3 meters width of the bottom in the beginning, smoothly widening to a 5 meter in the last 3 sections, reaching thus the width of the stilling pool. The chute ends into a stilling pool. The bottom of the stilling pool is 5 meters wide and 16 meters 20 centimeters long. 4 baffle piers are built at the end of the pool. The gate chamber at the beginning of our construction works was an existing structure. It represents a massive building with concrete walls dug into the dam body and reinforced concrete skeleton with brick masonry above the ground level. The gate chamber is supplied with spare parts and equipment for reparation works for the low-level culvert and the 3 water pipes. The designed volume of the potable water treatment plant is 225 liters per second. 15 liters per second of them are for its own needs, and the remaining 210 liters per second for water supply. The area around is thus organized to ensure place for a meteorological station and parking places for the staff. The main appurtenant structures on the territory of the potable water treatment plant are as follows: inlet and outlet distribution shafts, inlet and outlet measuring devices, technological building, administrative building, technological building for wastewater treatment, surge tank for the wastewaters, chlorination unit, service building for the exploration of the dam. The physical protection of the first sanitary zone along the whole perimeter of the dam is secured by a fence 1.8 meters high with 2 combined gates for pedestrians and vehicles, provided by locking mechanisms. Automatic security barriers have been installed, alarm and video systems, as well as a fence system of steel railings have been built. An important condition for the economical and social development of the municipalities of Medan and Rudozem, including as a tourist destination, is the provision of a normal supply of water of the required quality. Improving water supply for drinking will prevent the emergence of epidemic diseases by waterway. The population now has the opportunity to consume water meeting the Bulgarian and European standards. The construction of the dam Plovdivtsi provides a normal water supply for the population in these municipalities, while creating the opportunity for a better ecological condition of the Iskrets River and development of certain recreational activities. In addition, operation of the facility is expected to have a beneficial effect on the population. The opening of new jobs and the creation of recreation areas near the dam are expected. The construction of the dam will also help to regulate the water runoff and the protection against potential floods of the villages below the dam, as well as infrastructure and arable land, while improving the microclimate in the area of the lake. The dam Plovdivtsi has a positive impact on the river ecosystem under the wall, providing the water supply and creating good opportunities for the fish populations both in the water reservoir and under it. Gradually, opportunities for new habitats of the animal world and enrichment of amphibians and reptiles, mammals and birds in the range of the river are being created. The dam Plovdivtsi is the first such site to be built in Bulgaria for the last 30 years. To summarize, the implementation of the project ensures better water supply and responsible use of the water resources laid down in the state policy for the sustainable development of the water sector, meeting the requirements of the European directives in the field of drinking water supply.
Вятърът замита стъпките ни, първо страстите, после временно ни поглъща. Съгради се тази чешма, защото камъкът е по-траен от нас, а водата – вечна. Този надпис, издълбан върху стара чешма, ни е завещал преди векове незнаен мъдрец. И до днес хората в Родопите продължават да градят чешми, за да утолят жаждата на някой странник и да оставят след себе си нещо трайно и стойностно за бъдещите поколения. Защото водата не просто утолява жаждата, тя е история, чистота, живот и любов.